Topic for today, that is electrovalency. पिछली वाली क्लास में, previous class, what did we do? We have done the electrovalent bond or the ionic bond. ठीक है? And we know that ionic bond that is formed by transfer of electrons, which means that there are two types of ions which are formed. One is the cation and the other one is the anion. Cation किस तरह से form होता है? By loss of electrons, and anion किस तरह से form होता है? By gain of electrons. Then what do we understand by electrovalency? It is the capacity of an ion. Capacity of an ion to form ionic bond. ठीक है? It is the capacity of an ion to form ionic bond. अब जब ionic bond बन जाएगा तो we have already said that there are two types of ions present, which is the cations and the anions. Now how do we measure this capacity? This capacity is measured in terms of loss or gain of ions. Right? Which means how many electrons they are lost, not of ions, of electrons. How many electrons are lost or how many electrons are gained, that is going to measure the electrovalency. For example, if we are talking of sodium, we know that sodium has a capacity to lose one electron. Therefore, we say that sodium that is monovalent in nature. Right? In a similar manner, aluminium has a tendency to lose 3 electrons. Okay? So we say that aluminium is trivalent in nature. When we are talking of electrovalency or we were talking of electrovalent compounds, we spoke of one term which was known as the lattice energy. Okay, so let's do lattice energy in detail. How did we define lattice energy? We said that lattice energy is the energy required or energy lost when 1 mole of cations combined with 1 mole of anions to form a crystal lattice. So what did we also say, that lattice energy, that we can represent lattice energy by U, and lattice energy is the energy released, so it is a negative entity. Okay, because it is the energy lost when 1 mole of cations combine with 1 mole of anions. It is the energy released. Okay, now how do we measure the lattice energy? Lattice energy that is measured on the basis of a cycle which is known as Born-Haber cycle. This Born-Haber cycle is based on a law which is Hess law of constant summation. It is based on the law which is known as Hess law of constant summation. What does this law say? According to this law, if suppose we are doing a hypothetical reaction in which A is being converted to B, right? And the energy which is required to convert A to B, let's say that is equal to Q. Okay, required or released, whatever the energy changes, let's say that is equal to Q. Now, if we form B through an intermediate C, when A is formed into C, the energy changes, that is equal to Q1, and when C is formed into B, the energy changes, that is equal to Q2. According to this law, Hess law of constant summation, Q, that is the sum total of both the energies in which we are going to the main product through an intermediate. ठीक है? So this is Hess law of constant summation, and this law, that is the base of the Born-Haber cycle. How do we explain the Born-Haber cycle? Born-Haber cycle can be explained. Let's take the example of sodium. Formation of sodium chloride crystal. Okay. Now according to the reaction, we can say that Na that combines with Cl2 to give us NaCl, and the energy changes, they can be represented by delta H reaction, right? Delta H, that is the heat change for the reaction. Now this reaction does not take place in this step because the solid states, they cannot combine together, or the solid states cannot combine with other states directly to form the compound. Okay, so this goes through many steps together, and that entire steps, they are going to contribute towards the Born-Haber cycle. Okay, so let's see what are the steps. This is Na solid, this is gaseous, and this is also solid. Okay. Now Na solid will first be converted into Na gaseous. The energy which is required over here when solid is directly converting to gaseous state, that is known as sublimation energy. ठीक है? फिर उसके बाद this gaseous, that is going to lose one electron, and the energy which is required to remove this electron, that is ionization energy. ठीक है? So this is going to give us Na positive. Similarly, chlorine first gets dissociated into its respective ions. So the energy required over here, that is the energy of dissociation, energy of atomization. Okay? Then this is converted into the atomic state Cl gaseous. In order to convert it into an anion, we add one electron. Okay? So when we add this electron, the energy which is required over here, that is electron gain enthalpy, to give us Cl negative. Now we have two ions, Na positive and Cl negative. Both these ions, they are going to combine together to give us NaCl, and the energy which is released over here, that is known as lattice energy. In order to convert, or in order to calculate the lattice energy, we are going to use the Hess law of constant summation, which means that the total energy, that is the sum total of all the energies which are taking place in the process. Okay? So we have delta HR, that is equal to sublimation energy plus ionization energy plus half of dissociation energy plus electron gain enthalpy and plus lattice energy. Okay? From this data, we can calculate the lattice energy. Lattice energy will become equal to what? Delta HR, if we are taking this in bracket, so lattice energy, that will become equal to delta HR minus sublimation energy plus ionization energy plus half of dissociation energy plus electron gain enthalpy, that is equal to what? That is equal to the lattice energy. So this is how we calculate lattice energy on the basis of Born-Haber cycle. Okay? This we will also do in thermodynamics once again, but over here only this much is required for you to remember. Now over here we say that all the compounds which are having high value of lattice energies, that is more energy is released. So consequences क्या होंगे? All those which have high value of lattice energies, number one, they are going to be more stable. Why more stable? Because the system that is losing energy, and if the system is going to lose energy, that is going to become more stable. Okay? Then number two, all those having high lattice energies, they have high melting points. Right? Because the ions, they would make the crystal more stable, and anything which is going to be more stable will need more temperature to break it into the respective ions again. ठीक है? फिर then number 3, they have low solubilities in water. We say that the solubility that depends upon two energies. This factor is very important because you generally get questions from this, a conceptual question, that we say that any compound is soluble in water if it has higher value of hydration energy. There are two energies which are going to make any compound soluble. One is hydration energy and the other one is lattice energy, right? So if the hydration energy is higher, only then it will be soluble. Okay, we say if hydration energy is higher than the lattice energy, those ionic compounds are soluble in water. On the other hand, all those which have high value of lattice energy in comparison to hydration energy, they are going to have low solubility, right? So this is what lattice energy was all about. Let's go on to the general characteristics of ionic bonds. General characteristics. General characteristics of ionic bonds. ठीक है? General characteristics में जो first characteristic है, that is the crystalline nature. All the compounds which have ionic bonds, they are going to be crystalline in nature. ठीक है? So basically the units which are present in ionic compounds, the units present in ionic compounds are going to be ions and not molecules. Okay? Now these ions, they are arranged in a regular pattern. Okay, they are going to be arranged in a regular pattern, and this regular pattern, that is known as what? That is known as a crystal lattice. Okay, now because we say that the ions, they have a closed packed structure, as a result of which they have no freedom to move. So we are saying that ions have a closed packed structure, as a result of which they have no freedom to move. So mostly the electrovalent ions, they only exist as solids and they cannot exist as liquids or gases. Okay? So all ionic compounds, you can take examples. For example, we have sodium chloride, we have magnesium chloride, okay? We have copper sulfate. So all these, they are crystalline in nature, as a result of which we have zinc oxide. They all are solids, right? Then number 2, we come to melting and boiling points. Melting and boiling points. Now we already know that all the ionic bonds, the forces of attraction which are present in them, they are electrostatic forces of attraction. Okay? As a result of which the ions, they are very closely bound to each other. So their positions, they cannot be altered by just applying small forces. We have to give it a lot of temperature for the ions to break. As a result of which ionic compounds, they have high melting points. Okay? Because the electrostatic forces of attraction, they are one of the most आप कह सकते हो कि strongest forces of attraction which are present in constituent particles, right? And also one more thing, that the ionic compounds, they have sharp and fixed melting points. They have sharp and fixed melting points. Every compound has its own melting point which cannot be altered until and unless there is some impurity present in it. ठीक है? फिर फिर उसके बाद थर्ड, they are hard and brittle. What are the explanation which we can give for hardness and brittleness of ionic solids? Again, we say that the ionic compounds are hard because of the fact that they have strong electrostatic forces of attraction. ठीक है? Because they have strong electrostatic forces of attraction. What is the cause of brittleness? What happens in a crystal is that one layer can move over the other layer. Okay, so because in a crystal lattice there are different layers which are stacked up. So one layer that can move over the other layer due to some external force which we are applying. Okay, so because of that they can be broken easily and hence they are brittle in nature. Then the fourth property is solubility. Now this is an important distinct concept over here which we are studying. Solubility. We say that ionic compounds they are soluble in water. Right? There are a few reasons as to why ionic compounds are soluble in water. The first reason is that ionic compound is polar in nature, so is water. Water is also polar in nature. So we have a principle in chemistry which says like dissolves like. Because of this, the ionic compounds they are soluble in water. Okay. The second reason which we can give over here is that of dielectric constant. Dielectric constant of water, that is equal to 81. Right? So it has a very high value. As a result of which water has a tendency or capability to break the bonds of the ion. How does solubility or how does a compound be soluble in water or any other solvent for that matter? What happens is that the solvent, it has a tendency to break the bonds between the ions of the crystal. Okay? Once those bonds are broken, they are free, as a result of which they get solvated. So only those solvents they can dissolve solutes which have a high dielectric constant. In case of water, if we are saying water has the highest dielectric constant amongst all the solvents, which is 81, as a result of which it is said to be a universal solvent. Okay? So others they have low, like organic solvents like benzene and alcohol and carbon tetrachloride and ether, they all have low values of dielectric constant, so they are unable to dissolve the ionic compounds. Okay? Is it clear? Now, how do we explain about this principle over here, like dissolves like? We know that the crystal, it has both positive and negative charges. Okay? Similarly, water also has both positive and negative charges. So, the positive charge of water, that is the H positive ions, they go and attack at the negative terminal or the negative charge of the solute particle. As a result of which, there is strong forces of attraction which are going to be developed between the positive charge of water and the solute molecule. Okay? So when it is attracting the negative portion, so it can break the bonds between them. Similarly, the negative part of water that attacks at the positive part of the solute particle and it drifts it apart, as a result of which the crystal lattice that is broken and solubility occurs. Okay? Then third, another very important point we are going to discuss over here, that is the solubility also depends upon two factors, as I just told you. One is the lattice energy and the second one is solvation energy. Solvation energy may also be termed as hydration energy. All those solutes which have a higher value of hydration energy than lattice energy. All those which have a higher value of hydration energy than lattice energy, those compounds are soluble in water. Okay? Those compounds, they are going to be soluble in water. We say that value of hydration energy that depends upon size of the ion, right? Smaller the size, greater is the hydration energy. Okay, smaller the size, greater is going to be the hydration energy. There, that means that all those ions which have smaller values or smaller sizes, they can be easily soluble in water. For example, if we are comparing NaCl with cesium chloride, right? So down the group, what is happening? The size that is increasing, isn't it? So NaCl का size छोटा है, तो उसकी hydration energy ज़्यादा होगी. Okay, so if the hydration energy is more, then the solvation is also going to be more. Okay, now depending upon the comparison between the hydration energy and lattice energy, there are many ionic compounds which are not soluble. This is important because you get an MCQ, which of the following pairs are not soluble or which of the following pairs are soluble. So not soluble, you can write down, we have, for example, barium sulfate, BaSO4, barium sulfate, lead sulfate, calcium carbonate, calcium fluoride, lead sulfide, AgBr and AgI are insoluble because their hydration energy is less than lattice energy. ठीक है? Have you understood this point? Okay. Then after that we go on to the next fifth property, electrical conductivity. So the fifth property is electrical conductivity. Okay, now we know that the ionic compounds, they do not conduct electricity in the solid state. Okay, so they do not conduct electricity in the solid state. Why? Because there are strong electrostatic forces of attraction which are binding all the ions together, as a result of which the ions, they are not free to move or they are not mobile. Anything will conduct electricity only if it is mobile, if it is moving, right? So when the ions in the solid state are not moving, then they become bad. Ionic compounds, they become bad conductors of electricity. Okay, but they conduct electricity in the molten or, right? They conduct electricity in the molten or aqueous state. Why? What is happening over here now? When they are melted, then the ions, they become free. Similarly, in aqueous state, when we are putting it in water, water is pulling apart the ions, they are becoming free, they can move about. So as a result of that, they can conduct electricity, they become electric carriers. ठीक है, समझ आ गया? ओके, फिर उसके बाद सिक्स्थ, स्पेस आइसोमेरिज्म. What do we understand by space isomerism? Molecules which have the same molecular structure, right? But they are directed in different coordinates in space. That is what space isomerism is. Now we say that in case of ionic crystals, all the ions, they have fixed positions. Okay, because they are aligned in an inner crystal lattice. So because of that, the ionic compounds, they are non-directional in nature. They do not, you can say they do not, they are not aligned towards the three coordinates in space. Therefore, they are non-directional in nature. As a result of which, they do not show space isomerism. Okay? They do not show space isomerism. Then the seventh property is isomorphism. What do we understand by this term? Isomorphism. Isomorphism are, isomorphs are those ionic compounds having same electronic structure. They have the same electronic structure. Let's take an example over here. When we're talking of two compounds, one is NaCl and the other one is MgO. Again, this concept is important from your examination point of view. Now, in case of sodium, if we are saying the electronic configuration of sodium over here, that is going to become 2,8. Okay? Because if you are looking at the electronic configuration of sodium, it is 1s2, 2s2, 2p6, okay, and 3s1. Now when this is converted into Na positive ion, then this shell goes away. So what is the electronic configuration? In the first shell it is 2 and in the second shell it is 8. So we say that the electronic configuration is 2,8. Okay. Similarly, when we are talking of sodium, chlorine over here, the electronic configuration of chlorine is also going to be 2,8 in the outermost shell. Okay. Then we are going to magnesium. In magnesium also the electronic configuration that is going to be 2,8, and in oxygen also the electronic configuration is going to be 2,8. So if you are looking at both the compounds, they both are sharing the same electronic structure. Therefore they are isomorphs, which means they will have the same crystalline structure. All those which have the same electronic structure, they will have the same crystalline structure. So NaCl and MgO, they are going to be isomorphs of each other. Okay, have you understood? Then the seventh is ionic reactions. All the ionic compounds, they produce ions in solutions. Okay, so if they are producing ions in solutions, the reactions which are taking place, they are known as ionic reactions, and these reactions are very, very fast. Okay, for example, if we have sodium sulfate that is going to break into 2Na positive plus SO4 2 negative. Okay, and we are mixing with it barium chloride. Okay, so barium chloride is going to give us Ba2 positive plus Cl negative, right? Now as soon as we mix these two ionic compounds, it is seen that a white precipitate of barium sulfate is obtained. Why? Because these, as soon as they go in solution, they are going to give us sodium and sulfate ions. As soon as these go in solution, they are going to give us Ba2 positive plus 2Cl negative. ठीक है? So होगा क्या इसमें फिर? इसकी भी ions present है, इसकी भी ions present है. Immediately they will react together to give us a white precipitate of barium sulfate. So the reaction is very, very fast. Why? Because they are ionic reactions. Okay. Then we come to a new term over here, which is known as cooling curves. What do we understand by cooling curves over here? Cooling curves means that when we are trying to solidify any molten electrovalent compound, right? We have a melted electrovalent compound and we are trying to cool it, okay? And we are plotting a graph between temperature and time. Okay, we see that as we lower the temperature, with time cooling will start, okay? But at a particular temperature, we observe a straight line for a little period, and then again it can be further frozen down to lower temperature. Now this temperature at which you can see a straight line over here, this is the melting point of the electrovalent compound. Okay, so you can see over here that it's not a smooth curve. If this is point A, this is point B, this is point C, and this is point D. So over here at the same temperature, at the constant temperature, for a little time the graph that becomes a straight line, which means that till the entire melting point is obtained, till that time no further cooling is going to take place, right? Once the melting point is completely attained by the electrovalent solid, only then further cooling is possible. Okay? So these are known as what? These are known as cooling curves. Okay? So these are the properties of ionic compounds. Today we are going to do only till here, and we start with covalent compounds in the next lecture. Okay?